Hello, this is Dr. Brothers, and I'm going to be going over ECE 3872, Lecture 11, Human Factors and Design Thinking. So, Human Factors and Ergonomics, HFE, Human Factors, Human Senses, Cognition, Decision Making. Ergonomics, movements and proportions of the human body, relating movements or structure of living organisms. Physical performance limitations. So these are some of the basic definitions that we're going to use and talk about today. So HFE is commonly just called human factors. So this is all encompassing of human factors and ergonomics for when you're doing a design. Examples to raise awareness. Count the number of F's in the box on the next slide. Read through the sentence only once. Don't go back and count again. All right. Here's the sentence. Are you ready? How many did you see? There are 6 F's in this sentence. Most people see 3. Let's go back so we can see it again. Finished files are of the result of years of scientific study combined with the experience of many years. Did I get them all? 1, 2, 3, 4, 5, 6. One theory, the brain does not process the word of. Of makes a V sound instead of a hard F. Another theory is that the brain overlooks small words, such as of. So when you're looking at this, you're seeing something that's so routine, this of, this almost a supporting word in the sentence, that you completely overlook it. Your mind doesn't even stop on it as you're looking through it. If you apply that to like a human factors problem, we see this type of situation all the time where there is a system that's designed and there is something so basic, something so elementary about it that's just designed wrong. And you don't know why. It doesn't make any sense. So the human factors problem, these small little details have impacts that impact the overall system extremely negatively because these are how the users are interacting with the system. So it might be the best engineering piece of work that's ever been designed, but people don't like it because of the touch or the feel or the interface mechanism. This involves humans not behaving as expected. So I had a time when I was in the Army, one of the guys, he was working in a motor pool, which means he was a mechanic. And they brought in this new vehicle. It was a Humvee. And the guy said, hey, this is a Humvee. We want you to put it through the paces, see what it can do. And he said, okay. He was gone for about 5 minutes, and he comes back, and he's like, well, I broke it. They're like, what? How did you break it? You've been out literally like 5 minutes. And he's like, yeah, I just got in and turned the wheel all the way that I could and slammed the accelerator all the way to the floor. And after driving in circles for a couple of minutes, it broke. And they said, why would you do that? He said, I don't know. Being in the military was one of the best experiences that I had for many human factor designs. There was another time I was in Iraq, and we had received some new systems in our Humvee to defeat IEDs. They were counter IED systems. These were pretty big boxes that they put in the back of the Humvee in our truck, and they had big heat sinks on the top because basically what they were, they just emitted energy out into the air. So there was a big antenna on it, and as we drive along, if it would sense that there was any signals in the air, it would just put a huge amount of energy in that spectrum, and so it created a lot of heat by doing that. So there were these big heat sinks, these big fans. Well, of course, we had a lot of stuff, so as the soldiers were getting into their trucks, they took their backpacks and they just buried these boxes because they didn't know what these aluminum fans were. They didn't care. They needed a place to put their backpack. So they loaded up piles of stuff on top of these boxes of electronics, and we were driving around Iraq where it was 110, 120 degrees outside. So humans will do things that an engineer will not even conceive of. And one of the large parts about making systems is making them human-proof. So there's a resistance to purely technical interventions. So as we're designing things and building things, a lot of society will actually look on these things as a negative advancement. There was a great article that I read. It was from the 1930s when they were first coming out with automobiles, and the length to which local legislatures were going to try to create laws to prevent the adoption of vehicles because everybody had a horse, and these loud, rambling machines were a nuisance. And so they were trying very hard to prevent automobiles from coming into the area because they said they would scare the horses and somebody might get hurt because they'd get bucked off the horse. And so there were things like if they saw a horse coming down the road, they had to drive their vehicle at least 30 feet off the road and hide behind bushes. If they could not do this, they had to take their vehicle apart and spread the parts out along the ditch so no large part would scare the horse. Laws such as these that were passed in order to try to resist technical innovations. So a lot of what we will try to do as engineers is not only create a product that can be used, but we also have to make sure that society is ready for the product and that the legal infrastructure is ready for the product. A great one that's going on right now is self-driving cars. The technological hurdles are being solved much quicker than the legal hurdles. So example one, here's another example just of human factors, how systems interact with the world, how systems interact with people. Everybody hopefully has been to the IDC by now. And when you go to log out, first you have to scan your card, then you have to touch this button, and then you have to click this button in the top corner, close out the app. So you have to do three things in order to log out. So that is a lot of interaction with this machine just to walk out of the building. So many people overlook the second log out button. The peer instructor has to tell each person, be sure to hit the log out a second time. So this is an example of human factors designing. Here's another one from the IDC, unlocking the lockers. You have to lean over uncomfortably and look sideways at the lock when dialing in a combination because the way the hasp is attached to the locker and the way this little metal piece is angled. So what we want to do is start to think about this as a process. Like many things that we do in engineering, we want to use processes in order to break our own mental bias on a subject or our preconceived notion of how a product should be. So here is a process that we can go through to help us think about what we should do when we create a product in order to increase the usability of said product. So design thinking. We go through empathize, define, ideate, prototype, and test. And then you circle back to the beginning again. So this was first articulated in the 1960s, and it became mainstream in about 91, and Stanford's teaching in 2005. So empathize, the first thing you need to do is empathize with something. So different perspectives can impact product or services differently. End users are not the same as you. Different abilities, different knowledge, experience. A disabled person may require changing assumptions. If you're thinking about a product, and a lot of times when we're coming at a product from a design perspective, we as the engineers, as the designers, really want to be able to see inside it, to understand what's going on. But think about something such as the iPhone, or any modern cell phone actually, the main interface is simplified down where you basically have one button and then in this case a power button and a volume. So an extremely simple, streamlined interface on the cell phone, where when cell phones were first designed and engineers were first coming out, and I'll talk about this a little bit more in this presentation in a couple slides, it was something that was not the same perspective. And so it took quite a bit of iteration in order to come up with a product that basically could be used by everybody and was very intuitive to use. So, empathize. When you're doing this, one of the important things to do is not to talk, but to listen. Use open-ended prompts and then listen. Tell me about your workday. And listen, silence is okay. One of the things that we as human beings sometimes get uncomfortable with are long silences. But it's okay to have silence to let somebody conceive of it without giving them prompts of saying, oh, well, here's what I really am trying to get you to think about or to do. Okay? Observe what they do in their settings, not just what they say. So if you are trying to figure out this product for an individual, and remember, one of the things that I've been saying this entire semester, a lot of the times the customers don't really know what they want. And going back to the example of the automobile, Henry Ford once said if you ask somebody what they want, they would have said a faster horse, not an automobile. So it's the same way of thinking. A lot of times when somebody has an issue, somebody has a problem that they need solved, they don't actually know what they want. So one of the things that we have to do as engineers, as these people that are kind of bridging the gap between science and individuals, we're trying to take some technology and put it into somebody's everyday life. So we want to insert this technology into their life in a way that it will complement what they're doing. And oftentimes the best way to do that is to see them in their environment and see how they move through it. There is a wonderful documentary about Airbnb and how it got started, and the assumptions that they made as they were going through it. I think it's still on Netflix. If you have a chance, watch it. It gives a great perspective on human engineering and human factor design as they were going through that web page design. So ask somebody, can you show me how you do your daily routine, your product that we're trying, your process that we're trying to help automate? And then try to put yourself in their place. So this is one of the most important things that you can do whenever you're creating any type of product, is to sit and think about it as if you're the user, not the engineer. So you have to kind of get out of your own body and think of what it would be. Okay, the second thing, define. Consolidate widespread information you gather. What stood out? What patterns do you see? Develop an understanding of your user. Synthesize to a limited number of needs, and then articulate a specific, meaningful challenge to take on. This is very similar as to what we've been talking about with the requirements definition. One of the things that you have to do is look at all the data, look at the user needs that's out there in the world, and you have to take this user need and you have to collate it down into something that you can actually produce with requirements in order to address these needs. But these requirements also have to think about how you're going to address this in a way to integrate into the individual's life in a very easy manner. Ideation. So during this, you're going to use brainstorming, mind mapping. There are some other processes that you can go through in order to try to gain a sense of scope about the ideas. And this is really important when you're looking at this. And if you go back and you watch some of the old sci-fi movies and you see the products, you see the technology that they used in those movies, a lot of times the technology that came about was then trying to emulate what was in those movies. So for instance, the flip phone, that very, very simple product that's very similar to what we saw in the Star Trek communicators back in the day. So a lot of times you can look at something such as science fiction and say, okay, there's this science fiction world that's way out there. We're way away from that. But we want to move in that type of general direction. And so there's these limits of technology that now restrict us further. But then there's a very wide gap between the limits in technology and then the conservative designs and the resulting from the constrained idea space that comes down from that. So as you're looking at what can be done in this user space, you have to also take into consideration not only what is the limit of the technology, but what is science fiction, and can we push that boundary? So one of the things that we can talk about is like in Iron Man when he is designing his 3D suit and he's interacting with the space by moving his hands, and there is a hologram in front of him and he's moving things around and he's interacting with it. I was involved in a development effort where they were trying to use these Microsoft Surface computers, except they were 32-inch screen Microsoft Surface computers, in order to try to get something very close, very similar, that felt the same way as that Iron Man scene where he was designing his suits. And we were trying to do as close to the science fiction as we could within the limits of the current technology and, of course, cost. So a lot of what we need to do is try to figure out where we want to be. And oftentimes, again, the consumers don't know, we don't know where we want to be. Here's a great example of that. Let's look at phones. When cell phones first came out, you can see the old Motorola cell phones. And this image is from a website that's called the Engineers Forum, the evolution of mobile phones. And here's the website that you can go to and see this original image. So when they first came out with cell phones, what they did, they took a house phone and they slapped a battery on the back, and then they said, okay, now we're going to have an antenna sticking out the top of it, because of course if somebody wants a phone, they want it to be like a phone. Why would you want it to be anything else? And then they came up with the flip phones. And then Nokia had some amazing phones. They were indestructible. You could run them over with a car and they would keep running. Motorola, still a real big leader in this field, coming out with some real innovative designs, these clamshell, these flip phones that made you feel like you were from Star Trek. And again, the Nokia, Blackberry, they came out with a revolutionary design. Blackberry was an innovator. They came out with a full keyboard. And so now you could text and interact more rapidly. On these old Nokia phones, in order to send a text message, it was very cumbersome. You had to hit the same button multiple times to cycle through each letter of the word. And it was an extremely slow process to send a text message. So BlackBerry was an innovator. And here's Nokia. They're still, you look at like the original Nokia phone, and you look at this phone, they're very, very similar. And they still look a lot like a house phone, except they now have a little bit larger screen. BlackBerry, again, enlarging the size of the screen, but still keeping the full keyboard. And then we have some other phones that are starting to come along, but all of them pretty similar in design. Then we had the big paradigm shift. We had the first iPhone that came out, and the iPhone really changed everything. And when the iPhone first came out, it was revolutionary because it was no longer what a phone looked like. It no longer was just a simple input method. It was similar to the Nokia, but the iPhone was the first one that really hit it home. And they were successful because their human factors design. They were successful because they were looking at this idea space, and they were able to get out of the inner circle, and they were able to assess the limits of technology and live towards the edge, towards science fiction. And what they did, they incorporated the music players that they had been building. They incorporated the internet. They incorporated text messaging. They incorporated a full-color, large, smooth interface device. And they saw that people wanted to use their cell phones for much more than just a phone. And as we know now, barely anybody makes phone calls on their phone. After the iPhone came out, you can see the very dramatic and quick evolution of phones. BlackBerry They're still coming out with their full keyboard. A lot of people still liked it, but after BlackBerry, it fell off. Everybody replicated the iPhone design, and there was a dramatic paradigm shift from saying a phone should look like a phone from your home to now a phone should look like an iPhone. And that's what everybody thought. It completely changed the way that we interact with other people in our world, how we interact with our technology, even how we transport ourselves from one place to another. Another real quick story. When I was in college, I had a student publication at a conference, and so I went to this conference. It was one of my first conferences that I had ever been to, and it was absolutely amazing going and seeing all of these ideas. And at this point in time, I'll date myself a little bit here, this was in this region of cell phoneage. I think I still had a flip phone. I actually think I had a Motorola flip phone that was very similar to this black one in the corner. Legislation had just been passed that said that cell phones should have GPS. And I'm sorry, not legislation. The standard was just stated that cell phones would have a GPS chip in it. And part of that was for safety of the individual operators or the cell phone operators, where the emergency services could actually turn on that GPS chip remotely in order to find the individual. So this was a brand new technology where they said, we're going to put GPS chips in every cell phone. And I remember sitting at this conference, and there was a paper that was talking about the possibilities of what we could do with a cell phone in everybody's pocket and everybody's cell phone having a GPS chip. And they had this wild, crazy idea of tracking traffic patterns in real time using these GPS chips. Back when I was a student, this was a revolutionary idea. Now everybody knows it's Google Maps. You can pull out your cell phone now, look at your map, and see where the interstate is red, where it's green, where it's yellow, and get up to the minute calculations on how long it's going to take you to get from point A to point B. When I was in college, we didn't have that. We actually still had to print out paper maps and take them with us on our trips. It revolutionized the way we live, the way we travel, and now with the invention of self-driving cars moving into this area also, we're going to see a dramatic shift over the next couple of years in how our products are delivered to us and how business is conducted due to the ability of trucks to operate autonomously or in convoys with a single person leading them. And it's really going to change the way that we view our world. So we're moving more, again, towards a science fiction circle because we've made these small incremental steps with technology enablers that now will enable us to change the way we interact with technology. And that's a lot of what this presentation is about. How do you interact with technology? So all that, sorry, big side stories, but let's get back to how you now think outside the box, because that's what we're talking about. You don't want to just create a product and say, okay, we're going to create another cell phone. We need to have the buttons on it. We need to have the piece you talk in, the piece you hear, and that's all it is. How did they come up with the first iPhone? How did they make that leap from where they were to where it is now? And so 7 rules of brainstorming. How do you create these new ideas? Defer judgment. So when you're in something, when you're in a meeting and you're talking about ideas, don't automatically say, oh, that's silly, we could never do that. Hear it out, because even if it is some far-fetched, wild, crazy science fiction idea, you can maybe come to a middle ground where, yeah, their idea was crazy, but that led to another idea that was near reality, and that could ultimately be something great. Encourage the wild ideas. As you're brainstorming, don't just say, oh, we can't do that because of some problem. Those wild ideas get people to think outside this middle region. And a lot of times we're stuck inside this conservative dark blue region in the middle. We want to get out of there, brainstorming is a means of breaking out of that circle. So if somebody's breaking out of it, don't try to chain them down with saying, oh, that won't work. Let them go a little bit out into the realm of science fiction. You can always come back later. But it's very important. Don't encourage wild ideas. Build on the ideas of others. Stay focused on the topic. So if you're trying to brainstorm a certain idea, and obviously you're going to get a little bit outside, that's the one time you want to pull somebody back in and say, okay, well, we're not talking about chickens, we're talking about cars, so let's stay on cars instead of talking about chickens. You know what I mean? So if they dramatically get off topic, bring it back. Have one conversation at a time. As people are talking, especially on a topic that they're excited about, oftentimes you'll break off and have little sub-conversations, and the whole thing just degrades and you don't get anything out because there's no way to log and catalog all the ideas. So if there's little sub-conversations starting to break out and you are running the brainstorming session, definitely try to say, hey, hold on just a second with that conversation. We'd all like to participate. Let's finish this up, and then we'll hear what you have to say. You know what I mean? Be visual. Have whiteboards, have computer displays, have things that you can use in order to help communicate the idea. You might say something, somebody else might hear something different. If you have a picture in between you, it helps to communicate ideas. And go for quantity. You don't want to just say, okay, let's get 3 ideas up here so we can take it to the boss. Get a whole bunch of them. It's easy to throw ideas out later. So mind maps. Let's say that you've gone through and you have brainstormed a whole bunch of ideas and you arrived at an idea and you said, okay, this idea is really good. Let's take it and expand upon it a little bit, and let's search this through. I think everybody should have mind mapping software on their computer. It's great. This is one of the ways that I actually design the majority of my courses that I create from the ground up, because it gives you this ability to organically connect ideas together and create a logical flow. So put your general main theme in the center of a page. Example, how do you steer a car? And then draw branches to sub-themes from the center. So you could use your hands, you could use your voice, you could use brain waves, going a little bit into science fiction region. So you can see how these kind of tie in with brainstorming. With brainstorming, you can get a whole bunch of ideas real fast, write them all down. Then you can come back with mind maps and say, okay, we went through the list, we really like these. Let's expand on these a bit and see how they can go out and touch into the world. Now, add images to invoke thought or get the message across. And then add at least 2 main points to each sub-theme. So use hands. You can just use your hands directly or use hand gestures. You can develop your own voice recognition. You can get a license. So, et cetera, et cetera. You can expand these out and expand these out and expand these out, and it becomes this big web of connectivity on how everything can come together into a whole. This method can also is very effective when you're trying to do a system style breakdown, and this is something that I've talked to a lot about in class, is that V architecture of designing down one side and building up on the other side. If you have a system and you want to decompose it into subsystems, you can use this type of mapping, and you can start to see as you get out and out and out which area has too much content in it and which doesn't have enough, and then you can combine and merge and move them around. So really, really a powerful idea, this mind map tool. After that, you want to go into prototyping. Quick, cheap, minimize your upfront investment. Get something that you can touch as soon as you can. User can interact with and provide feedback. So this is one place, and a lot of times when we're doing our initial, I'll tell a couple of stories about this. When we're doing our initial prototypes, a lot of times what we'll do is in research, just convey the idea to the customer. We'll 3D print what the circuit card would look like. So we have an idea and we have a schematic. Basically, we've done our bill of material. We've got all the sizes of our parts. We 3D print what the schematic would look like, not using a schematic, just out of plastic with the correct mounting holes. And then we'll put that together so we can actually hand something to the customer and say, yeah, look, this can flip up and this is what's inside and here's how it's going to work. And they can touch it and feel it and get more of a feel for what's really going on. Another example of that, but a little bit more in depth. I was working on one research effort, and it was a little bit of money that they had given us up front to do a capabilities study to see if it was possible. One of the main things that we did with that money was we built an empty box. That's all we did. We built an empty box. It was a beautiful box. And it was for a line replaceable unit, and so it had two big handles on it, and on the back of it, it had all the blind mating connectors. And what we did, we took it to the customer site, and we went to their unit, and we pulled out one of the operational line units, and we set it aside, and we picked up our box, and we put it in, and it mated. And all it did, it connected the coolant hose up. It was a liquid-cooled system. It connected the liquid coolant up, and it ran it through the box. And then it lit up the front panel. And that's all it did. It didn't have any guts to it. But it showed the user how easy it would be to put in our box. And then on the front panel, we had enough of the interaction that they could really get a feel for how well it will work with their system. And based on that, they sold it and gave us a follow-on, and that turned into an extremely successful research area. But it was all about creating a real cheap prototype. There was no guts to it. It didn't do anything. It was literally a box that we could plug in and say, look, we can plug into your system, and that was enough to sell it. So having something that the customer, the non-technical individual, can touch and feel, it doesn't have to work. It just has to be an idea. All right. Identify what is to be tested. This should answer a question. And so you can see the next stage of this process is to test. So you need to identify what's going to be tested. And this is going back to the V-style diagram that we've talked about before. These ideas go together. These are the individual tools that you're going to use on those stages of the V. And so you come up with these ideas, you mind map them out, you come up with a set of requirements. Now you need to figure out how you're going to test a given set of requirements. So you take those requirements and group them together and show how you're going to test something. Don't become emotionally attached to one prototype. I told a lot of the groups this semester as you're going through building your robots, your sculptures, that don't get attached to a single idea. Be open to changing, because if you get so far down the path and it's just not working, be able to navigate back to a different path and go forward. And I know that there have been several groups that have done that this semester. They went pretty far down the road, and then they said, this isn't working, let's adapt. And I had other groups that have went so far down the line, and they are still pushing down that same line, and they're bound and determined to get it to work. That's okay. Just be aware of what you're doing, and don't stick with an idea just because you like it so much. Have an open mind and look at what you are trying to do and build something that is related to what you're actually trying to do. So prototype something real fast. And then the end thing that you need to do is test it. Like I said, with the box, what we were testing was the mechanical interface to their system. So we took it, we plugged it in, we showed that coolant ran through it, and we showed that on the front panel, the LED indicator turned on, meaning that we had interfaced their power correctly. That's what we were testing with our prototype. It was a subset of all the things that it had to do. It was actually nothing of what it actually was doing, but it was a box that plugged in and turned on, and the user could touch the outside. So we were testing that we could interface with it. And that test is very important. So you need to solicit feedback from the customer to see what's important to them. Continue to ask why as you're going through this development cycle. When we were building this box, the engineers that were on the team, including myself, I thought it was kind of like a joke. I was like, we're building an empty box. Why are we building an empty box? That's not actually the why that it's asking to ask. But the individual who was running that program, he understood what the customer was concerned about. So we were asking, the engineers were asking, why are we building a box? But the guy who was leading the program, he was asking the customer, what are you concerned about? What do you want us to solve? So he was asking and getting feedback this whole time from the customer, and that's what's important. Learn about the problem, not the solution. That's what I'm saying. He understood the problem with the customer. There was another story. This is just a random story. I don't know if there's any truth behind it. There was a customer, and he called this elevator company, and he told the guy who ran the elevator company, he said, I need faster elevators. I'm getting complaints from all the people in my building. The elevators are just too slow. I need you to come and speed up the elevators. So they sent one of their high-up guys over to check and see what was wrong with the elevators. Well, the high-up guy timed the elevators. He rode in the elevators, and they actually were really fast. He didn't think that there was any need to increase the speed of it. So then the individual sat in the lobby and watched people and realized that the problem was not the speed of the elevators. The problem was that people were bored as they were waiting at the door to the elevator. So he solved the problem. He put on mirrored faces to the door. That way, when they were inside the elevator or outside the elevator waiting for it, they could look at themselves in the mirror, check their hair, check their makeup, check their suit, make sure it's straight, and the complaints went away. Oftentimes, the customer has no idea what they actually want. They just know that there are complaints about the current thing, and they want the complaints to go away. So our job oftentimes as engineers is actually to figure out what the problem is. And that's the first step in solving the problem, is to actually know what the problem is. Don't ever underestimate the value in understanding the problem. Let the user interpret the prototype. So once you get the thing, once we had that box, once we brought the box to the customer site and plugged it into his system, we let him turn the knobs, flip the switches. It didn't do anything anyways. It had no guts in it, but he was happy. He moved it in and out a couple times. He used it, and that made him happy. That made him understand that we knew how to interface with his system, and it made him very happy to see that it worked. So have user compare multiple prototypes. So oftentimes, again, with 3D printed model, when we have our PCBs and we can rapidly print something that is just a piece of plastic, but it gives an idea of the layout and the touch of the buttons. That's something very, very useful to the user. You can take 2 or 3 or 4 designs and say, hey, we've come up with these different ideas. How about you look at these and see what you think? This semester is an ideal example of this. The problem for this semester was to create a sculpture, and the sculpture should play music and be aesthetically pleasing. The way in which the groups have decided to have music input into their machine are just a multitude of options, from waving your hand above the sculpture to different sliders to 2 devices that you turn, and it has tilt sensors that are inside of number of different ways to interact with the machine. So don't limit yourself. Again, think of that cell phone example. The original cell phones, all of them, represented what they thought people wanted, which was a replication of the home phone. But that's not at all what people wanted. Somehow, iPhone figured it out. So think about options of how to interact with the user. All right, here we go. This is where we're getting to some of the meat of this presentation. This is what can make you valuable. This is why Steve Jobs was so rich. He looked at this chart. Do they want this desirability? Apple is the leader at creating products that are desirable. Should we do this? Viability. Thinking about the viability of a product, they were making a phone, but the phone was more expensive than most phones had been in the past. And now if you think about the cost of one of these phones, if you would have went back to the early 2000s and told someone the cost of a phone currently, the majority of people would say that's not viable. You can't sell a phone for that much because they think it was just a phone. So viability, is there a customer base for what you're trying to sell? And then finally, feasibility. Can you actually do this? This gets back to the sci-fi structure, talking about the 3D interaction with the machine from Iron Man. You know, we can't do that yet, but how close can we come to it? So you want to land in the middle. You want something that's desirable, viable, and feasible. And if you can find that, then you're in the right spot. All right, that is everything for today. I hope you enjoyed this lecture, and I will see you in class next week.